1, which says that 3x plus y is equal to 10. So here, our x is now, when x is 3, when x equal to 3, so automatically we're going to have 3 times 3 plus y equals to 10. And it's going to be 9 plus y equals to 10. Then our y will now be 10 minus 9. So our y equals to 1 at that point. Then the second case, when x is equal to 27 over 11. So we have 3 into 27 over 11 plus y equals to 10. So automatically this becomes 81 over 11 plus y equals to 10. And our y now becomes 10 minus 81 over 11. We can also make this fraction, and we look for the SCE. 11, this time is 110 minus 81 equal to, so this becomes 110 minus 81, then we have 29. So we have 29 over 11. That means, therefore, our y equals to 1 or 29 over 11. So that means when x is equal to 3, y equals 1. And when x equals to 27 over 11, the y equals 29 over 11. So that is the answer in both cases. So example 2 now. We have to solve these equations. We have x squared minus y squared equals to 27. Then we also have x plus y equal to 3. This is equation 1 and this is equation 2. If you look at these two equations very well, we discover that the first one is a quadratic equation, while the second one is a linear equation. The second equation is simpler than the first equation. So from equation 2, x equals to 3 minus y. That's from equation 2. Then this becomes equation 3. Substitute equation 3 into equation 1. Then we're going to have, anywhere we see our x, we replace it with 3 minus y. So in the first case, we have x squared, so it will be 3 minus y all squared minus y squared equals to 27. Now, instead of going through the rigor of expanding this way, which does not save time or is time consuming, then here we expand by this short method. This 2, place it on this, it becomes 3 squared, and that is 9. Use this 2 to multiply this, we have 3. 2 times 3, that is 6. 6 times minus y, then we have minus 6y. Then place this one on minus y, it becomes minus y times minus y, and that is plus y squared. You have the minus here, which is minus y squared equal to 27. Then we have 9 minus 6y plus y squared minus y squared becomes 0. It will cancel. This cancel out. Then we have 27. Then bring this one to the other side. We have 6y minus 6y equals to 27 minus 9. And that means minus 6y is now equal to 18. So you have 18. Then here we can divide both sides by minus 6. So if we divide this by minus 6, we are going to have y. If we divide this one by minus 6, minus 6, then this one becomes 3. That's y now becomes minus 3. So being able to calculate our y to be minus 3. Using equation 2 to calculate our x, using equation 2, which is x plus y equals to 3. When y is equal to minus 3, automatically this becomes x plus minus 3 equals to 3. That's x minus 3 equals to 3. Then our x becomes 3 plus 3, and our x will now be 6. So therefore, when x equals to 3, equals to 6, y equals to minus 3. So x equals to 6, y equals to minus 3. Question number 1. Use a graphical method to solve the equations. Y equals to 2x squared 2x squared plus x minus 2, comma, they have y equals to 4 minus 2x. Given this condition, a scale of 2 centimeter to 5 units on y-axis and 1 centimeter to 1 unit on x-axis. So in this situation, we are not to draw a freehand graph. We must comply with the instruction that is given. So the instruction given here is that 2 centimeter to 5 units on y-axis, then 1 centimeter to 1 unit on x-axis. Given that the value of x ranges from minus 3 to 2. So in so doing, the first thing we have to consider is that the value of x has been given to be ranging from minus 3 to 2. So automatically we compute a table of values for that, which you have minus 3, minus 2, minus 1, 0, 1, 2. So we stop at 2 because our x ranges from minus 3 to 2, where you have your x, minus 3 is less than or equals to x is less than or equals to minus 2, so we stop here. And since this is our graph, we have to plot two graphs. This one is a quadratic graph, while this one is a linear graph, simply because the highest power of our x here is 2, while the highest power of our x here is 1. So the first thing we do is that to solve this, to calculate our values for y conveniently, we have to resort to a particular method by arranging this in a fascinating manner, and that can be done by simply saying 2x squared, that's the next value, next term here, then followed by x, then followed by minus 2 before we now have our y. Our interest is to get the corresponding value of our y. Since we know our x, we want to calculate the corresponding value of our y, or corresponding values of our y, so that we can plot the graph of x and y. So here, the first, when x is minus 3 squared, that is 9. 9 times 2, that gives us 18. When x is minus 2 squared, 4. 4 times 2, 8. When x is minus 1, minus 1 times minus 1, 1 times this, 2. When x is 0, automatically everything becomes 0. When x is 1, 1 squared, 1 times 2, 2. When x is 2, 2 squared is 4, times 2, 8. So we've been able to resolve that. And this one is x, we write all what we have here. Minus 3, minus 2, minus 1, 0, 1, 2. Then you have minus 2. Minus 2 is a constant where we replicate the constant throughout the column. 2 minus 2 minus 2 minus 2 minus 2. Now, our interest is to resolve what we have here in these 3 rows, 1, 2, 3, excluding this and excluding this. This minus this, that is minus 5. Minus 5, this becomes 13. Minus 2 minus 2, minus 4. Minus 4, 8 minus 4, that's 4. Then minus 3, minus 1. Minus 2, minus 2. Minus 2, 1. Minus 2, 8. So automatically, therefore, we'll be able to resolve our corresponding x and y values. Where you have this minus 3, the corresponding value of y is 13. When you have minus 2, the corresponding value of y is 4. When you have minus 1, the corresponding value of y there is minus 1. When we have when we have 0, the corresponding value of our y there is minus 2. When we have 1, the corresponding value of our y is also 1. When we have 2, the corresponding value of our y is 8. So these are the corresponding values of x and y which we plot with the graph. Now, for this particular graph, which is a linear graph, we have 3 critical values. I decided to use minus 3, 0, 2. You can pick every other values, but I believe for convenience, minus 3, 0, and 2 are the respective critical values of x with respect to this linear graph. So in that situation, we have a linear graph of y equals to 4 minus 2x. Then when x is minus 3, automatically my y will be 4 minus 2 into minus 3, and that gives me 4 plus 6. So my y becomes 10. When x is 0, using this same equation, we have our y to be equals to 4 minus 2 into 0, and my y becomes 4. Then when my x equals 2, then my y will become 4 into minus 2, minus 2 into 2, then this becomes y equals to 4 minus 4, and that is 0. Then by computing a table for this, when x is minus 3, my y is 10. When x is 0, my y is 4. And when x is 2, my y is 0. So this is what, so I will plot this graph, which is a quadratic graph, and we also plot this graph. But before we plot this graph, we should know that this automatically, because of the fact that the coefficient of our s squared is positive, we have a minimum graph. That means the graph will be minimum. But if this had been negative, then we have a maximum graph. But in this situation, we're going to have a minimum graph. That means the tip of that graph will be facing downwards. So it will be facing downwards. So the bottom will be facing downwards in this way, which is a minimum graph. And this will be a linear graph that will cut across the minimum graph so as to determine our coordinates or the critical values.